So here it says, use the graph of y equals the square root of x to graph y minus 2 equals negative square root of 3x plus 3. So we're going to move that 2 over. What kind of stretches and compressions do you see? Well, we got a negative out in front. What is that going to do? It's going to flip it, and it's going to flip it over the x-axis because it's outside. It's going to affect the y-coordinate. So that's going to be a flip, a vertical flip over the x-axis. The 3 inside will, the first 3, horizontal compression. We're going to multiply x by 1/3. The next 3, the plus 3, translation 1 to the left. Yes, so we have to do the factoring thing. So what we're going to do first, before we do anything, is we're going to rewrite this equation. We're going to rewrite it with the 3 factored out, and then put the 2 on the other side. So you can see how tempting it is going to be to, you see that plus 3, you're going to just say 3 to the left. But we have to write it in that factored form. So we know that we're going to multiply x by 1/3. If we look at our, so we have our original points, then we do all of our stretches and compressions, and then we're going to do all of our translations. So the first thing, what do we have? We have a negative outside. That's going to multiply y by -1, and we're going to multiply our x values by 1/3. So any reflections that are there to get put with the stretches and compressions. Then we have 2 translations. We're going to go left 1 unit and up 2 units. So a key point on a square root graph that we have right here that continues on forever, a key point is going to be 0, 0, because that's your starting point. Considering that we're going to have to multiply our x coordinate by 1/3, if you didn't want fractions, what would be the next point you would use? You could use 3 in the square root of 3, but then you're going to have to deal with square roots, which might not be as nice. 9 and 3, because the square root of 9 is 3. So that'll be a nicer point to use. It's not wrong if you decided to use 1, 1 or 4, 2, but this will make things a little bit nicer. So there's our 2 points that we're going to use. What's going to happen to 0, 0 when you multiply by those things? It's going to stay 0, 0. But 9, 3, when you multiply the x by 1/3, you're going to get 3. And y by -1, you're going to get -3. Left 1, give us -1 and 2. Up 2, +2, and -1. If you were doing this on a test, I would often suggest drawing a new graph, but if you have a different colored pen and you'd like to put it on the same graph, we could label these points. We're going to have -1, 2. Look at the scale here. Can you see that your x scale is going by 2's? So -1, 2 is right there. And 2, -1 will be right there. This is our key starting point. Where did that point go? That point went to here. So that will be our starting point for our graph. And when we graph our final graph, we have to go through and say, does that look like the right shape? Okay, I've got my starting point. I'm going to have a reflection over the x-axis. Okay, so it makes sense that this is going down. Then it's been squished by a factor of 1/3, moved to the left and up 2. So that seems to be the right shape based on those ideas. But that's a good thing to do at the end as a quick check. And this was a good example because it had that special note we talked about, making sure that we factor out all of our horizontal stretches and compressions when we also have a horizontal translation.